Welcome to Brain Vision.
16.66. So we have the displacement versus time of some wave that looks like this at x equals 0. And we'd like to find the phase here of the wave. So first of all, the function being plotted, we set x equal to 0. So this function here being plotted is y sub m times times the sine of negative omega t plus phi. So the slope here is positive, which means that the derivative is positive, of course. Evaluated at t equals 0 is greater than 0. And so this means that negative cosine of phi, because at t equals 0, if this goes away, we don't care about these to get the sine of this, because you can divide by y sub m and omega on both sides, and you still get that negative cosine of phi has to be greater than 0. So this implies that our angle is somewhere in the second or third quadrant. And so we need to be careful when we, in evaluating the arc sine for the angle, to make sure that we get an angle that's in the second or third quadrant. This is the first quadrant. So we know that when time is equal to 0, we have y of 2 millimeters. We know the amplitude is 6. Omega t is going to be 0 plus phi. So we can just ignore the 0, sine of phi. And so inverting this to get our angle, it's just going to be the arc sine of 1/3, because 2 divided by 6 is 1/3. So this is either 0.34 radians or 2.8 radians. But we know that our angle has to be in the second or third quadrant, so that has to be 2.8 radians. And also, if you add or subtract any integer multiple of 2 pi to this, of course it's the same, because you're just going around one way or the other in a complete circle. So you could express this in other ways, but this is a positive number less than 2 pi, so that's usually how one likes to express angles.